Hello, good afternoon. In today's video, I'll be explaining how to construct bisectors. The first thing you need to understand is that a bisector is a way of cutting things into two equal parts. So we can bisect angles, we can bisect side measures. All right, I'm going to start this with a straight line. I'm going to draw a straight line here, 8 centimeters long. So, all right. Since I want to cut this line into two equal parts, I need to go to the middle, which is 4, and then I'll place my protractor here, exactly 4. Well, as you can see, since we have a straight line, the angle I have here is 180 degrees. So if I want to bisect it into two equal parts, I need to cut it exactly in 90 degrees, because half of 180 is 90 degrees. So I have my protractor here. I'll just draw a line bisecting my angle. All right, so here I have 90 degrees here, 90 degrees here. The distance from this extremity to this middle point is the same as the middle point to the other extremity, because I also bisected the side measure. If I wanted to continue it, I would have to measure here. This, let me get my ruler. Let me place it here. Let me rotate it properly. Okay, so I know that this line here is 5 centimeters long. So I'm going to stretch it 5 centimeters down here. They don't look perfect, but this is because I don't know exactly how to use these tools properly. But if they were exactly in the same place, we would have the same distance from this extremity to this point being the same as this point and this extremity. This extremity to this middle point the same as this middle point to this extremity the same. Here 90 degrees, here 90 degrees, here 90, and here 90. All right, this is the first part. All right, let's continue the activity we were doing before. So basically what we did in the last video was constructing perpendicular bisectors. You need to have in mind that when we say the word perpendicular, we are talking about things related to the 90 degrees angle, okay? Because perpendicular lines, they always make 90 degrees angles. So in this video, you'll be learning how to construct rhombuses by using only perpendicular bisectors. So I'm going to draw a line here 10 centimeters long. Oops. Okay, 10 centimeters long, and I'm going to bisect this line, okay, with a perpendicular line. So I'll draw this line here, okay, and let me measure how much it is, how long it is actually. Okay, so let me make my ruler like this. Okay, so it's about 3.5. Well, not very friendly, this line here, so I'll make it 4. Make it 4. Okay, let me stretch it until it's 4. Okay, so now we have a line 4 centimeters long, and then I have to stretch here 4 centimeters as well. Okay, let me label my vertices now. So call this A, call this B, call this C, and I call this D. All right. The only thing I need to do now is to connect one vertex to the other. So AB, BC, CD, oops, CD, and DA. Alright, so now we have our rhombus. So we just erase the inner lines. Alright? Well, one thing that you need to notice about rhombuses is that their four sides are equal. So this line segment is equal to this one, which is equal to this one, which is equal to this one. And another thing, I'll just draw it again, the inner lines, and you notice one thing. Actually, I've said this before. You can see that these inner lines, they intersect. I'll call it the middle point E. They intersect here at E. Put it here. So the distance from A to E is the same from E to C. The distance from B to E is the same from E to D. Alright, now let's check the angles. Let's check this angle here first. This angle, we're going to count it this way, is this angle goes until here. So this angle, counting from 0 from left to right, is 105 degrees. This other angle here, I have to count it from right to left, is 85 degrees. Actually, sorry, let me check here, 75 degrees. 75 degrees. This one here is going to be the same as the opposite angle to it. Let me check. Oops. 105 degrees. And this one is going to be the same as its opposite angle. Here, this way, 75 degrees. So basically that's our rhombus. It was constructed by only using perpendicular bisectors. So the properties you have to remember, the opposite angles were the same, okay? And all the sides were the same. And the distance from a vertex to the middle point is the same as the middle point and its opposite vertex. We'll continue in the next video. Alright, this is going to be the last part of the video. Now, instead of drawing a rhombus by using perpendicular bisectors, we're going to bisect the angle, and you see that we will get a rhombus just by using bisects. Okay. First of all, I'm going to draw a line here, a line like this. Okay, and I will use this line to make an angle. I want the angle to be exactly 50 degrees. So let me get it back to 90. I'm gonna make it 50 degrees over here. 50, yeah, it would be here, 50 degrees. So I need to have a line over here. So let me draw it. I'm gonna draw it over here. Good. So now I have an angle of 50 degrees over here. Let's just measure it again to see if we didn't make any mistake. Okay, it's right, 50 degrees. Now, I'm gonna get my compass. Okay, oops, like this. And I'll place a dry tip here. And I'll choose the distance. The distance is not important, okay? Remember that in a rhombus, all the sides will be equal. So I'm gonna choose this distance here, okay? What's important is to keep this distance in the compass, okay? We cannot change it. If we change it, we won't have a rhombus because the side measures will be different, okay? And now I'll draw an arc, like this. It seems as the arc was too big for this arm here of my rhombus, so actually the arm from my angle, so I'll just erase it and we'll make it a little shorter. Okay, like this. Great. Now I'm going to label this extremity here, vertex A. This other one, B. And this one here, C. And I'm going to erase this arc here. Whoops. Not a good idea, because I need to see exactly where's my B. Okay, so I'll place now the dry tip of my compass on point B, and I'll keep the same distance, and now I'll draw an arc from B to A, as you can see I'm doing here. Alright, now do the same thing, but now I'll set the dry point of my compass here on point C, and I will draw an arc from A to C, like this. And I know how to draw a fish. Okay, you see that the two arcs, they coincide this point here. I'll label it D. So here's D. Now the only thing I need to do is to connect the vertex to another vertex. So I'll connect vertex A to B, B to D, D to C, and G to A. To make it easier to visualize, I'm going to erase all these arcs here. Oops. And here we have our rhombus, okay? Let's check each side measure to see if they are equal. This one here, about 6.3. About 6.3. About 6.3 again. And about 6.3 again. Alright, so all the sides were exactly the same. Now let's measure the angles. This angle here, 50 degrees. This angle here is 130. This angle, I'll have to rotate it like this. This angle is 50 degrees. And this angle here, let me rotate it, is 130 degrees. Again, the opposite angles were exactly the same and all the sides were equal. Alright, if we draw lines like this connecting a vertex to its opposites, again we have the same as before. This distance to the middle is the same from this. This distance is the same, B to the middle point is the same as E to the middle point to C is the same as B to the middle point. Well, I hope it's clear now. Okay, I hope this video was useful and helpful, and that's it for today. Well, just one thing I forgot to mention. These perpendicular lines here, they bisect the angle in half. So here it was 50 degrees, so here now we have 25, here 25. Here it was 130 degrees, so now I have 65, 65. Let's measure it and check. So the angle here was 130 degrees. So this angle here, like this, is exactly 65 degrees. 65 degrees. Because, as I said, we bisect the angle. And now the explanations are over.